A significant amount of force is applied to joints when sticking landings in gymnastics. In order to reduce the amount of force applied to the joints, alterations can be made with regards to impulse. To do this, the amount of time in which the force is applied is increased to decrease the overall force. Looking at the momentum equation can help explain this relationship. Change in momentum is equal to force times time, and impulse is equal to the change in momentum. Therefore, impulse is also equal to force times time. When landing a skill, the impulse remains constant, and the equation reveals an inverse relationship between force and time. Knowing this, if the overall time over which the force is applied is increased, the amount of force on the joint would in turn decrease, and vice versa. In the videos that follow, the change in the angle of the knees upon landing is representative of the increase in time over which the force is applied to the joint. The greater the change in knee flexion upon impact, the greater the time value. This in turn decreases the force applied to the joint. During jump 1, knee flexion is minimal. Therefore, the time over which the force is absorbed is small. This leads to force on the joint being high, and it is difficult to stick the landing. Jump 2 demonstrates greater knee flexion than jump 1, but the time it takes to absorb this landing is not large enough to decrease the amount of force on the joint and stick the landing comfortably. In the final jump, the athlete demonstrates the greatest amount of knee flexion upon landing, and therefore increases the time value in the impulse equation. This decreases the overall force applied and allows her to stick the landing. Any further increase in time spent absorbing the landing decreases the force on the joints. By lengthening the time it takes to absorb the landing, not only does the athlete have greater chance of sticking, but they also reduce the risk of injury by preventing excessive force on the joints.